In this video, we are going to see how to evaluate antiderivatives. So in the first problem here, g of x is negative 4 cosine x minus x, and you're asked to find the antiderivative of this. So we are going to use this uppercase g to indicate the antiderivative of the lowercase g of x function. So what is an antiderivative? It is nothing but you're going to just ask yourself what would give negative 4 cosine x. So basically the question is the derivative of what is negative 4 cosine x is your question, right? So then you know that this has to be negative 4 sine x, isn't it? Because if you take the derivative of negative 4 sine x, you're going to get negative 4 cosine x. So this is going to be negative 4 sine x, right? And then you're going to ask yourself the derivative of what is x, right? So then you know that if you were to take the derivative of x squared, you'll have 2x. So therefore, this has to be x squared over 2. So we're not going to be asking this question repeatedly in order to answer all of them. There are rules that we are going to follow. So for example, what does the power rule say? The power rule says basically like this process, this is the derivative, and when you work backwards, what you get is the antiderivative. So the power rule is that if you're taking the antiderivative, so for example, if your g of x is a power function like so, and if you want to take the antiderivative of that, then the rule is that you add 1 to the power and then you divide by the new power. So if you're going to apply that rule, so the current power is 1, we are going to add 1 to it, that gives us x squared, and then we are going to divide by the new power, which is 2, and that is the antiderivative. And then because we are coming up with a family of function here, so we are coming up with a general antiderivative, we are going to add a plus c to the answer. This is important. Now, in the next problem, what I'm going to do is I'm going to rewrite this as a power function first. So I'm going to convert the positive exponent into a negative exponent. And then when I take the antiderivative, what do? I use the constant multiple rule. I bring the negative 2 as is. Then I take the old power, add 1 to it. That gives me negative 2. And then I divide by the new power. And so simplify this, my answer will be 1 over y squared plus c. Okay, so now we're going to do the same thing here. We are seeing the integration symbol. So we're taking the integral, which is also like we're just taking the antiderivative. So how do you do that? Apply the power rule here, add 1, 1/3 plus 1 is 4/3, and then you divide by the new power plus 2/3 over 2/3 plus 6x plus c. Simplify this. This can be written as 9/4 x to the power of 4/3 plus this is 12 over 2. So 6x to the power of 2/3 plus 6x plus c is your answer to this indefinite integral. So in the next one, you have a product. There is no, we are not going to apply any product rule or anything like that. So all that we have right now in our hands is sum and difference rule, constant multiple rule, power rule, and so on. So you have to distribute this and make it into a polynomial function. So I'm going to distribute. So I have 3x times 4 is 12x minus 3x squared plus 4 minus x, right? So this is what I have. I combine the like terms. I have negative 3x squared plus 11x plus 4, and then I take the integral of this, and my answer will be negative 3x cubed over 3 plus 11x squared over 2 plus 4x plus c. And this can be simplified to negative x cubed plus 11 over 2x squared plus 4x plus c as your final answer. Okay. So again, here I'm going to convert the next problem also into a power function first, like so. So this is what I have. Then I take the antiderivative. So I have 3x to the power of negative 3 over negative 3 plus 2x minus 3x to the power of negative 1 over negative 1. And then I simplify this, and this becomes 1 negative 1 over x cubed plus 2x plus 3 over x plus c as my final answer. All right. In this problem, what I'm going to do is I'm going to split the terms first. Okay. So then I simplify it. So my original question can be rewritten as 4x cubed minus 6x dx. So now I take the integral. I have 4x to the power of 4 over 4 minus 6x squared over 2 plus c. I simplify this and my answer is this. Okay. So here what I'm going to do is I'm going to factor my numerator, and then I'm going to simplify this fraction. This and this gets cancelled. So my question now becomes just x plus 6 dx. So I take the integral. I have x squared over 2 plus 6x plus c. Now at any time you are not really confident whether your answer is correct or not, you can always check by taking the by differentiating. So for example, if I were to take the derivative of this, what do I get? I will have 1 half times 2x plus 6, and derivative of a constant is 0. So what do I get? I get x plus 6, which is what I took the integral of. Okay, cosecant squared. So remember, the derivative of tan x is secant squared x, and the derivative of cotangent x is negative cosecant squared x. So which means the antiderivative of cosecant squared x is positive cosecant squared is negative cotangent x, right? And then plus 2 theta squared is plus 2 theta cubed over 3 minus 3 theta squared over 2 plus c, right? No need to simplify this. You can leave your answer like that. Okay, so here what I'm going to do also is I'm going to rewrite my original question like so. So I'm splitting it up. And so this can be written as 2 cosecant squared y plus 3 cotangent y cosecant y dy. So this one, how did I simplify it? Cosine y over sine squared y can be written as this. So basically I have two fractions, right? And so cosine over sine is cotangent, 1 over sine is cosecant. And then what are the antiderivatives? So cosecant squared. So, we just saw that. We saw that the derivative of cotangent is negative cosecant squared. So the antiderivative of cosecant squared is negative cotangent. And then cotangent cosecant would be cosecant. And that's your answer. Negative cosecant I meant. Okay, secant squared antiderivative is tangent minus x plus c is your answer here right away. Again, secant squared antiderivative is tangent. Secant tan, the antiderivative is secant plus c is your answer. 3t squared will be 3t cubed over 3 minus 2 cotangent t plus c. So this can be simplified as t cubed minus 2 cotangent t plus c as your final answer. Okay, here what I'm going to do is I'm going to distribute first. Okay, so when I distribute secant, so secant times tangent, what is, okay, let's rewrite everything. Secant can be written as 1 over cosine. Tangent can be written as sine over cosine. So this is your first term plus 1 over cosine times 1 over cosine plus 1 over cosine times cosine. Okay. Now, when you simplify all of this, what happens is this is can be written as secant theta tan theta. It's better to leave it like this, okay? Plus secant squared theta. 1 over cosine is secant, right? So I'm just rewriting it like this. But this and this goes away, so I get plus 1 d theta. So now the antiderivative of secant theta tan theta is secant theta. Secant squared is tan theta plus c is my answer. In this problem, we are not asked to find a general antiderivative, but a particular antiderivative. So first I go ahead and take the antiderivatives. So this square root of x can be thought of as x to the power of 1 half. So that is 4x to the power of 3 halves over 3 halves plus 6x plus c. But we are given one point in my antiderivative as 1 comma 8. So I'm going to replace x with 1 and f of x with 8. Okay, so x is 1. So simplify this. I should have simplified this here before, but I didn't, but that's okay. 1 to the power of 3 halves is 1. 4 over 3 halves is 8 thirds. So I simplify this. C becomes 2 minus 8 thirds, so that is negative 2 thirds. Right? 2 minus 8 thirds. Yeah. So then my particular antiderivative can be written as f of x equals, so this is 8 thirds x to the power of 3 halves plus 6x minus 2 thirds is going to be my answer. So do the same thing here. My antiderivative will be secant b plus c, right? Now apply this 0 comma 2 is the point given to you. So 2 is equal to secant 0 plus c. Secant 0 is 1. So which means c is 1. So then I will write my particular antiderivative as secant b plus 1. Okay. So a derivative is given. If you take the antiderivative of this, you'll get the original function, right? But before I do that, let me distribute and rewrite my derivative, okay? So 7x to the power of 7 minus x is the derivative function. So which means if I take that antiderivative, I'll get g of x. So g of x is 7x to the power of 8 over 8 minus x squared over 2 plus c. Then I put this point 1 comma 2. So that means 2 is equal to 7 eighths minus 1 half plus c. So 7 eighths minus 1 half is nothing but 7 eighths minus 4 eighths, which is 3 eighths. So c will be 2 minus 3 eighths, which is 16 minus 3 is 13 eighths. So which means my g of x is going to be written as 7 eighths x to the power of 8 minus x squared over 2 plus 13 over 8. All right. So then again, take the antiderivative. I will have 4 sine u plus cosine u. That's right. Okay. So then I substitute 0 is equal to 4 times sine pi over 2 is 1, cosine pi over 2 is 0. So this gives me 4. Which means C is negative 4. Okay, so then I write my function f of u is equal to 4 times sine u plus cosine u minus 4. Okay, again do the same thing. Take the antiderivative. So sine x will be negative cosine x plus sine x plus c. Then I substitute 3 is equal to negative cosine pi plus sine pi plus pi plus c. Cosine pi is negative 1, negative times a negative is a positive. Sine pi is 0. So which means 2 minus pi is c. So then I put it together to write my f of x as negative cosine x plus sine x plus 2 minus pi. Velocity to position. So we have to write the position function now. So if you take the antiderivative of velocity, you will get the position. So s of t is equal to 2 sine t plus c. So then I substitute 0 equals 2 sine 0 is 0 plus c, which means c is 0. So my position function is nothing but 2 sine t. So same thing here. Position is nothing but 4t squared over 2 minus cosine t plus c. So then I substitute 0 equals 0 minus 1 plus c, which means c is 1. So then I write my function s of t is equal to 2t squared minus cosine t plus 1. Now acceleration to position. So remember that when you go this way, if you have position function, velocity function, acceleration function, right? So the derivative of position gives you velocity. The derivative of velocity gives you acceleration. Now, when you're working backwards, velocity function is retrieved by taking the integral of the acceleration. So if you take the antiderivatives of 0.2t, you will get 0.2 t squared over 2 plus c. This is your velocity function. Now take this value, initial value given. So 0 is equal to, so because we are going two steps, right? We are going from acceleration to velocity and velocity to position. I'll just use two subscripts for my constant. So I've called this C1. So I substitute 0 for t, then I get 0 plus C1, which means C1 is equal to 0. So what is my velocity function now? My velocity function is 0.1 t squared. That's it. This is my velocity function. Then I take the integral of velocity to get the position. So basically what I'm doing is I'm doing this, right? So then I had 0.1 t cubed over 3 plus the second constant. Then I take the second initial value given, s of 0 is 1. So that means 1 is equal to 0 plus c2, which means c2 is 1. So what is my position function then? It's 0.1 t cubed over 3 plus 1 is my position function.